Okay, so here we are supposed to do inter VLAN routing. Inter VLAN routing means I want this PC1 in VLAN 2 to communicate with PC2 in VLAN 3. By default, it is not going to be permitted, but if you want, you have two ways. Instead of this device, you can use a layer 3 switch, or you can use a router like this. A router on a stick. This design is called as a router on a stick. Actually, you have two options. You can take two cables and you can do like that, but that is not a feasible option. Instead of that, what we will do is we will deploy it in a router on a stick fashion. Now for that, we require this device to be in a proper IP subnet. What we'll do is we will do it in a better way. This here, we will put in an IP network 10.0.0.1 and it's a 10.0.0.254 is the gateway. So for you to go out of your network, the first thing is you must have a default gateway, right?
Yeah.
And 20.0.0.254. And can you assign two IP addresses, two primary IP addresses to this interface? You cannot. Why? Because if you assign this address first and you assign as a second address, it will be overwritten. Now what you have to do is first assign the basic IP addresses to these PCs. Second, create these interfaces, create two VLANs over here, VLAN 2 and VLAN 3, and configure this link. Let's do that first. So what should be the configuration of that? On the switch, we are configuring enable configure terminal. If you want, you can give it a host name, but not required. Interface F0/1. Switch port mode is access. Switch port access VLAN 2. See, if I do not create a VLAN and I put an interface inside a VLAN, this operating system will create a VLAN for us. So I'll simply go ahead and say interface F0/2, and I will say put this interface please in VLAN 3, right?
Yeah.
So, and the link that goes to the end to the router, this link will be my trunk link. Switch port mode is trunk. This is the overall configuration of my layer 2 switch. This is a layer 2 switch. Let us copy the let us first give the IP addresses. Let's start from the bottoms up way, because Friday is coming and we are in the party mood, right? So bottoms up, thumbs up, no worries. Yeah. I'm just joking. This one is 10.0.0.1, 10.0.0.254. This one will be 20.0.0.1 and 20.0.0.254. This switch has one interface in VLAN 2, another interface in VLAN 3. Let's click here and let us push the configuration. Show VLAN brief. Correct configuration.
0.0.2.
Okay, so what I'll do is here this PC and this PC, and 3 is not configured as a trunk. Why? Because I'm using another 3 is a default. Let us configure terminal interface F0/3. Switch port mode is trunk. No shut. Show interface trunk. Okay, it's off by default. Let me go on the router, and on the router I'll just turn on the interface first. Let me check enable configure terminal interface gigabit 0/0. I'll say no shutdown to it. As of now, I just turned on my physical interface. I am not configuring anything else on this physical interface. What will I do then? And the language of a router on this gigabit 0/0 switch uses .1q encapsulation. What encapsulation is used on your gigabit 0/0? Let us say show interface, show IP interface gigabit 0/0. It's disabled. Show interface gigabit 0/0. It says encapsulation is ARPA. So the encapsulation on this interface is different and the encapsulation on the switch is different. Let me check whether the trunk is up. Yeah, the trunk is up. Now you have to create logical interfaces under this interface. So what are we doing here is we will create two logical interfaces over here. Inside this, we will create two logical interfaces. One interface will be a part of your pink VLAN. For example, one interface will be a part of pink VLAN and the other interface will be a part of your orange VLAN. Like that. Pink and orange, like this. Now, physically, the cable is this, but internally, we will create two logical interfaces. Logical means I will create two sub interfaces. How do you do that? Configure terminal, interface gigabit 0/0. But after that, I will say dot and hit a question mark. See how many sub interfaces can be created, how many logical interfaces can be created under one physical interface. The amount is huge. I'll simply say 2 because this resembles with the VLAN 2. So I created a sub interface under my physical interface. Here I will say encapsulation .1q and 2. This 2 is the VLAN number. So I'll say yes and I will say IP address. This IP address is 10.0.0.254. This is the address of the gateway of PC1 and I will simply come outside. Again, I will say interface gigabit 0/0.3. One more sub interface, his encapsulation is also .1q and he is 3. Means the data that is coming over here belongs to the VLAN number 3. IP address on this this interface will be 20.0.0.254. And see, show IP interface brief will tell you that there are two sub interfaces and both have these IP addresses. Understand one thing, the physical interface must be up. If the physical interface is down, the logical interfaces will never come up. Let us ping our end devices 10.0.0.1. Can I communicate with him? Yes. Can I ping 20.0.0.1? ARP will happen and then communication happens. So how is my communication happening over here? This guy is going to the switch. The switch adds a label and this is sent on the logical interface wherein the router picks it up, understanding the encapsulation. Now, by default, the router's job is to do what? Is to do routing. And he will route the packets only if he has the entry in its routing table, right? Now, I will ping from here to the router. The data goes to the router's interface. The router checks the routing table. He checks, where do you want to go? Do you want to go to 20? Oh, it is directly connected. He will send the data over here. Let us see. Can I ping 20.0.0.254? Why? Because it is on the router itself. Can I ping 20.0.0.1? Yes. Inter VLAN routing is happening. Why? Because my address is IP config. My address is in the 10th subnet. I belong to VLAN 2, but then also I am able to go and communicate with this device who is in another VLAN and another subnet. So this is inter VLAN routing using a layer 3 device, a router. Getting it? This is router on a stick. There is one more implementation of the same kind. What we will use is we will use a multi-layer switch instead of these two devices. What is a multi-layer switch? It is same like a router you can think of. It is a switch, but it can act as a router also. What I'll do is I'll simply take these PCs and connect them over here. Yes. Now, by default, it is a layer 2 switch only. No layer 3 functionality is carried on this one as of now by default. Let us first do the very basic configuration of this one. The very basic configuration is to put the interfaces into VLANs. First, actually, you must create two VLANs, but these devices are very cooperative. They will all automatically create the VLANs for us. So what I'll do is I will take this interface on my F0/1. I have a device in VLAN 2, and on my second interface I have devices in VLAN 3. Let us go ahead and do that. The configuration is almost the same. A little difference is there. See, the device tells us access VLAN does not exist. Creating VLAN 2. What did I do? I simply created two VLANs in the backend. So I told him, switch. This interface belongs to VLAN 2. This interface belongs to VLAN 3. Nothing much. Let us go on the switch and say, show VLAN brief. Yes. So here it has created two VLANs by the name of VLAN 002 because we did not give it a name, and VLAN 3 of this one and this interface. By default, they will not be able to communicate. Now, if I say there is no router over here, so for us to do inter VLAN routing, we require a router somewhere, and we don't need a router. Why? Because this switch can do basic routing for us. But how? As of now, there is no IP address over here. Where will you apply an IP address? You can apply an IP address on the physical interface also, but we will not do that. What we will do is instead we will create logical interfaces, but not like a router. By that I mean to say I will create interface VLAN 2. This is your SVI. It is a switched virtual interface. SVI is interface VLAN 2, and on this SVI I will give an IP address 10.0.0.254. And no shut is not required actually. Only VLAN 1 requires no shut. So what did I do? I created an interface VLAN, and I will say again interface VLAN 3 IP address 20.0.0.254.255.255.255.0 and exit. I can say show VLAN brief, but interface VLANs do not come in here because interface VLAN will be show IP interface brief. It will be at the last. See, VLAN 1 is by default off. So if you say interface VLAN 2, then you can give it an IP address also. Same on layer 2 devices also. If you want, you can create an interface VLAN. But as of now, just see what is happening here. VLAN 2, this has an IP address. Can the PC over here ping 10.0.0.1, 0.0.254? Can he ping the switch? How is the data being sent? The data is being sent over here like this. There are two logical interfaces on the switch. This guy goes and pings to the interface that it belongs to. Right? Can he ping the interface that he does not belong to? He does not belong to. See, by default, this switch is also a layer 2 switch. He will not allow the data from this VLAN to be sent to the other VLAN. Let us test it. Let us go on this PC, and can I ping 20 the gateway on the other side 20.0.0.254? See, this is a layer 3 switch, but by default it is not acting as a layer 3 switch. The ping will not happen. Why? Because the switch is doing the forwarding and filtering decision. He says data from VLAN 2 will not be sent into VLAN 3. But what can be done to do that? So if I cannot ping the gateway over here, how will I be able to ping over here? Not possible, right? So there is one small command. Just have to say IP routing. This will fire the routing engine on your switch. So if the switch is not been given this command, it will not do routing. As of now, show IP route, if I say, it has created a routing table like a router only. Before I gave IP routing, if I would have checked on this place, this routing table wouldn't have been populated. But now it is populated because the routing engine has been fired. And let us see the difference as of now. Let us go on this PC. Earlier, this PC was not able to communicate with the IP address on another subnet. Now, why is it communicating? Because this packet reaches the router, reaches your switch, for you can say. This packet reaches your switch, the switch checks the routing table like a router, and then he sends out over here. Then it is allowing the packet to go outside. Then only he will allow it to go to the other VLAN. If the routing engine is off, he is a layer 2 route switch, you can say. Getting the point? Okay, so let's go and ping. The final job is this guy must be able to ping this guy over here. Can we ping from our device to 20.0.0.1? The R should happen and the ping comes successful. So this is inter VLAN routing using router on a stick and using a layer 3 switch instead of router. Getting the point?